Hey, welcome back to Invisible Machines. I'm Josh Tyson, a contributing editor here at UX Magazine, and I'm joined again by our resident visionary, Robb Wilson, CEO and co-founder of OneReach.ai. Robb and I are co-authors of the best-selling book, Age of Invisible Machines, and this podcast is where we continue our explorations of agentic AI. Today, we're excited to welcome Omar Santos, Cisco's distinguished engineer of AI security. Omar is also co-chair of the Coalition for Secure AI, which brings together leaders from Anthropic, Google, Microsoft, OpenAI, NVIDIA, and others. Today, we're going to talk about the ways that security is becoming a dynamic, ever-present layer as more and more software is being created on the fly, driven by natural language. The very idea of a security department feels both antiquated and woefully inadequate. And as Omar is here to explain, it's truly an organization-wide endeavor. So we're going to explore how to manage teams composed of humans and AI systems, what the advanced orchestration of AI agents actually looks like, and how increasingly sophisticated simulations will be used to mitigate risk. Enjoy this percolating conversation with Omar Santos.
Good.
Yeah, Robb actually brought something up kind of interesting as we were prepping for this call moments ago, this idea that like security is now the new programming in a way. You know, the act of actually programming software is becoming more and more sort of conversational and ephemeral, and apps can just be kind of, put together at a moment's notice to accomplish a goal. But over top of all that is the myriad security concerns that arise with technology this powerful and sort of this probabilistic and sort of unpredictable. And I wondered if what your sense of how that interplay works now, like between programming and security, and how it all fits together.
Yeah, as a matter of fact, actually, that's a perfect timing, even though I have been traveling a bit. But we did a few announcements. I won't ever say we, of course, I work at Cisco, but I co-lead the Coalition for Secure AI with Google, Anthropic, OpenAI, etc. We're trying to see what is the most relevant and timely advice that we can give to the rest of the industry whenever it comes to AI and security. And it's exactly what you mentioned. Basically, security becomes like the next language, if you will, because it has to be embedded. It cannot be. So one of the big things that we have been working on, the Coalition for Secure AI, is redefining how we handle identity and access for AI agents, right? Especially making sure that these, systems, get enough access exactly whenever they need it. Just in time permissions model, right? That scenario.
I mean, there's no biometrics.
Absolutely not. Yeah. We also started with the typical analogy that, if you go back in time and you ask one of those a blacksmith and they say, hey, if I can automate, I think that we talked about it in the previous call, but if we can automate your production line of horseshoes, and of course they're gonna think that you're crazy, they're gonna fear about their job, but the underlying technology that actually changed, it was not so much of the horseshoe, was actually the whole transportation movement.
Yeah.
So one of the things
it's like we're not going to give our AIs a fake eyeball so that they can log in, or a fake face, right? Because that's the security we use. That'd be like the horse and buggy thing. Again, it's not a replacement to the horse. It's not a replacement to the buggy. It's a whole new vehicle.
Yeah, and the challenge is that I think that we still have in mind of the problems of yesterday, and nobody knows, right? What's it going to be in the next 18 months? The scalability of these models now, right? So they're becoming better. We were talking about coding, right? So they're becoming a lot better. That's the kind of the return on investment that most organizations are going to get. You move faster, you code faster. However, these models are running in what I call, the crawling mode. Why? Because we're about to put them in a jet, which are the Stargates of the world. These huge centers.
But what is happening out there? Like, what's what's coming as you're out looking at these massive Stargate data centers?
So what we're seeing or we're talking about is actually the scaling loss on where these models now are behaving pretty well whenever it comes to actually coding. And of course, depending on the metrics that you use, you may get different results with them, but definitely they're increasing. It's not that they're going back, and we're definitely hitting. We have hit a few walls, but we have actually circumvented them with mixture of experts and etc. But whenever it comes to infrastructure and these new data centers, the magnitude of this multi-gigawatt data center nowadays makes you think that these models that we are very impressed and they're changing every week nowadays, how are they going to be perceived, or how are they going to scale in 18 months whenever we actually start putting them into this infrastructure? So, and one of the things that we are actually working, and we just announced that, so I'm putting my Cisco hat on, is not about just running models in one data center, but what if you don't have a lot of power, and a lot of, architectural elements? Can we put 2 or 3 of these data centers working together, right? And yes, as a matter of fact, we created a new chip called the P200, where now we're putting, these designs of these data centers. So if you have one in Texas, the other one in Arizona, up to 1,000 miles, we can actually connect to 51.2 minutes per second. So my first reaction to that is like, oh, we're building Skynet, right?
Yeah, totally. Yeah. I think it's important to point out that a lot of people is, this concept of model is a little vague, right? Like, I have more specific granular version of model. And so when we talk about more infrastructure, we're not just like simply talking about the ability to train these models. We're talking about the fact that the solution to an LLM building an application correctly may not just be that the model itself, the underlying algorithm improves, but just the sheer fact that we do it 20 times concurrently and pick the one that worked, right? And so as we think about like scaling data centers and scaling the models, like, is that a new model, or is it just the same model, but then threading it, just like you would generate an image and get 4 versions? Why not get 10 versions of code and then deliver the one of the 10 that worked? Which essentially, yeah, you could say that's a model, because someone might slap a model product name on the fact that it splits the workload and runs it in 10, and then, map reduces it back to like one result. But in essence, that's what we're talking about, right? Like compute exponentially now, not writing one program or writing 20 at the same time, picking the one you like the best, or it picking the one you like the best, and then that making it more reliable, which is crazy compute-wise, because we're really talking about compute solving the problem, not data, not algorithms, but actual just compute and hardware.
Yeah, you're spot on, and make it for the audience. The 2 major categories that you have in these AI workloads, one is training a model, as you mentioned, right? And that was very, very computationally intensive, and still is. We haven't solved that. Second, it is pretty expensive, right? But it's getting cheaper, which is a good thing. And just like you mentioned about training models, if you go back 1 year, I'm not talking about 20 years ago, just 1 year, you see the significant difference on the way that you do evaluations and you automate a lot of things. And data, at the end of the day, is the core of AI, because there's no AI without data. However, now you can also generate data. So for training, exactly what you mentioned is that now you have federated learning with different models. You kind of dispose them, and you train 2 or 3 of the variants of quote unquote the model. And then it's not just one model by itself, it's the mixture of experts, right? So you have one that is very specific, one that is doing distillation or diffusion techniques for images and so on, one for audio. So that's what you see more in the frontier AI companies. But then the other side is the inference, right? What you mentioned, especially around test time compute and so on, because you train a model, and of course, it's a continuous process, because you're not gonna just stay in there and just have GPT-5 for the next 20 years. But at the same time, what the main demand is actually inference, right? And that's the users use these things, that especially now that some of these companies are actually building this agentic capability built in within their frameworks. Like you saw last week, actually, I was at OpenAI Dev Days last week, whenever they introduced their agent kit and they introduced, their agent platform. And you're going to see, that Google, follow it after that. And all that is compute, right? Somewhere has to run. So it's exactly what you mentioned. The techniques that you're going to see coming up in the next few months is around consensus scores whenever it comes to test time compute. Like you have 2 or 3 outputs, so we call inference. And then at the end, you come up with some type of consensus score to give you the better answer, whether it's to create code, to do a meme, or to do something in the scientific element. So pretty exciting. Really exciting.
I was thinking at some point getting a project done, and I think real soon, you just sort of give the system a budget, tell it what you want, and it'll just use up all that compute and give you the best it can within the confines of that budget. So you sort of say, whatever, I want to build a game, of chess, and I want to do it for $2. That's my budget. And it's just gonna work on it. And then at the end of that budget, you'll get the best that it could come up with. It might have threaded it out to 10 different, like you said, different models. It might use the same model, just with different context, prompting, both, right? And then ultimately deliver you something for $2. And if you want a better game, you up your budget and you say, well, what can I get for $10? And that's it's interesting because that's how we do it with people.
That's exactly right. You're so spot on. As a matter of fact, one of the points that we made in that announcement in the Coalition for Security AI for the next 12 to 18 months is how to create guidelines for hybrid human AI security teams, right? So in our case, it's around security, but it applies to everything. Exactly what you just mentioned right now. If you think about it, how humans will do this, I will hire a team. I will give them a budget. I will have some type of onboarding process, to the engineers and project managers and so on. I do some type of evaluation type of criteria. Right? So some criteria. If you're going over budget, I'm putting more pressures. If you're going under, I'm going to give you some rewards and so on. All that definitely can apply to an agent, right? So you have to figure out how to manage teams where some of your team members are actually AI systems, right? And some of them are, not AI systems, and the other one is the scaling norms, and where human in the loop, in my opinion, this is just my opinion, the Cisco, the coalition, is kind of dead, right? So it has to be a human on the loop, right? So there's a lot of new conversations about self-critics and critic systems and so on, because you're not going to be able to scale.
Yeah.
This episode is brought to you by OneReach.ai, the runtime for AI agents. Their GSX platform provides turnkey private architecture and tools for building enterprise-grade agentic solutions. Recently, I worked with the team at OneReach to create an agentic companion for the second edition of Age of Invisible Machines. So now when you scan any of the QR codes found in either edition of the book, an agent is there to provide additional insight using a custom knowledge base. There's also a newsfeed feature with updates on Agentic AI, as well as this podcast, and a book resources skill that provides clickable galleries of footnotes from each chapter. All of it built using the revolutionary Generative Studio X platform. Learn more at OneReach.ai.
There's a book, I'm going to pump a book here. It's called The Checklist Manifesto. It's a great read. I think like a lot of the answers are held in there. It's focused on healthcare, but it really gets into the idea that far fewer mistakes would be made by humans if we operated more on a checklist basis.
Yeah.
And I think these are going to be critical for AI agents. It's pre-flight checks, just like we do in airplanes. We worked on the Boeing 787, the Dreamliner, and checks and checklists are key, right? The whole thing, the reason you can fly in a safe environment is because of checklists. It's one of the number one tools. I don't know him, so I'm not pumping his book for any other reason than I think as we work with agents within our company and with customers, checklists we find to be absolutely not just instruction, not just guardrails, but you could think of checklists going far beyond guardrails, but also inclusive of guardrails. And I think that kind of gets into your point we made in our last conversation, where security is not a thing anymore. Everything's security. There's no, if you have a security department, you're going to be completely an outdated company. It's like the HVAC department.
You're so spot on. And as a matter of fact, I really hope that folks around, that know me, listen to this, because this is exactly the message that we're trying to actually drive in the last few months. One, if you think about it, in any organization, of course, they have a security function, maybe large. I'm spoiled, so mine is large. Some of those I don't. But they say, oh, we have a security team, security is taken care of. Let's innovate somewhere else. Now we have to actually flip that 180 degrees, saying security has to be embedded. And I really love, and you can tell that this is actually not even planned, because I want to write a book now to actually see if apply that to before, during, and after. Mm-hmm. So before, there's a lot of, I call it hype, but it's actually reality. It makes complete sense. Whenever you ask an agent to do something, most people are thinking about just a normal prompt. Like, I'm going to give it a task, and then the agent will figure out. If you do that, you're going to fail. Especially even in coding. So there's this hype now, or this term called spec-driven development, which I love, which is you actually have a really good set of criteria on what is going to be the product, the end product, what are going to be the checklists of the planning phase. And then if you think about it, if you think about security, you can start embedding some threat modeling in there, right? At the end of the day, those checks are threat models. The other one is during. So during, of course, guardrails, a lot of these AI coding agents that I'm honing into coding now, but like whether it's Cursor, Codex, Cloud Code, etc., now they have rules. Well, you can actually implement this type of checklist and so on, not only for security, but for other things. And then after, for code review, what is a code review? A series of also
checklists. Yeah, it's great you're bringing this up, because being a coder myself, I am completely surprised that it's kind of gone like schemorphic for me even. First you add AI to my IDE, right? But now when we get into the world where it's going to make 10 apps concurrently or 10 functions concurrently, the IDE has no place. So now why do I have this IDE? So Cursor's like this moment in time, like it's just a bridge to get you to the other side where I don't need. So what do I need? I need a new IDE that is just all about security checklists. It's like check on all of these things that are within our company's policies, within our canonical knowledge, within the sort of security check, the same thing that a quality control person might do in a factory, when something rolls out, you're like testing and checking and double checking that everything that happened in the factory was correct. And you're putting that little stamp on it to say this was checked by person Y, so that they know who to hold responsible if that thing goes out wrong.
So you're spot on. Whenever it comes to AI coding agents, I think that a lot of people were focusing on the IDE, and then what you had is a chatbot with an IDE, and then after the chatbot, it evolves into workflow files, rules, and so on. But it's still human-driven, so human in the middle. And what you saw with like companies like OpenAI and Anthropic, they started actually going outside of the IDE. Like whenever Codex was released, I think OpenAI was actually a little bit ahead of themselves a bit, because it was background agents, right? That you give access to a GitHub repository, like that agent will read all your GitHub issues. So as long as you actually have a good GitHub issue, it's like, go ahead and code, right? I'm gonna come back. The challenge was the longevity of the planning phase, all the multi-step operation that an agent will do. So short-term, long-term memory. Now we have agents as of today, probably that will change tomorrow, that can reason for 30, that can operate for 30 hours, right?
Right.
And that's what we're gonna see now with, the evolution of all this compute, that is gonna be like, hey, at the end of the week, there's gonna be 5, 10 agents, 100 doing consensus scores with tasks, and they're probably gonna figure out the questions that you never even thought about of asking for a given task, right? So background agents was definitely a thing. And then, however, since most of the software developers still operating in IDE, that's where you started seeing something that was pretty particular. And this is, again, my opinion, not the opinion of everybody, but you started seeing the Windsurf, Cursor, the co-pilots of the world in the IDE space, and in between, the CLI.
Right.
Why? Because, of course, the way that you interact with the computer is changing. And now I can have an agent that is not only about creating code, but organizing this, creating FAQs. You can have sub-agents now that is not around just creating the code. It's like every time that an agent creates a code, another sub-agent documents it. Another one is actually publishing out. Another one is doing, or 3 of them, code review.
Yes.
Another one is a security review.
Yes.
And
I love this because, like, the Git, to me, Git's like the next IDE, that at some point we don't need Git repositories for the purpose of like deploying code, because a lot of code is just going to execute on the fly. But what we know is that code is a container for our business logic, for our company rules, and that AI agents can just read the code to understand the canonical knowledge and processes of a company, not necessarily to read the code to write code or to read the code to update code, but just to read the code to understand the company better, because nobody wrote that into a document somewhere. And so now it's kind of like Amazon Q, how it's migrating mainframe to AWS services, right? This same idea that you can have an agent read the code to find out what the onboarding process might be for X, Y, or Z, just to execute it without doing anything to the code.
When can the agent be reading the code and working through checklists too, right?
Yeah. Creating a checklist from the code. Yeah.
Mm-hmm.
And right now they actually do that. One of the most powerful things, still human driven, but most people, whenever they inherit code from somebody else, they're really, really careful of not breaking that, right?
Right.
Especially a new engineer, right? New engineer, you don't want to touch this thing. You are driven to the task. Like, you have to be really prescriptive. Now with all these agents, it not only can explain it to you once, but in many different ways that you can actually understand it. But at the same time, it can start documented all those notes to itself. So then it can actually iterate in the code, later. So if you look at all the planning phases of these agents right now, or the planning mode is what most of the companies actually include, is that they create their plan and you can edit it, but they create the plan and then they create subtasks and then they go from there. But you mentioned something extremely relevant, and it's around the checklist, what I call before, during, and after. When we're in security, we are releasing an open source project called CodeGuard. And what it is basically exactly that, is checklist or rules that we translated, and we have automation to translate to all the coding agents. So Windsurf, Cursor, Copilot, the Clouds of the world, etc. And what it is, even though all those models have all the security best practices already in their training data, they're non-deterministic. Now you can decrease temperature and be more deterministic, but in some cases actually render some elements, more challenging, or I will not call it useless, but more challenging. But what we do is if we create a series of rules that, think about that, is the SDLC of agents. Like in the past 25 years, we train a human, and then that human at 2:00 in the morning has to remember the training of not to introduce a SQL injection, but it's already overworked, so he's probably going to skip that anyways, even though if he has it. Think about an AI model probably has it here, but the non-deterministic element is going to introduce vulnerabilities, and that's what we're seeing nowadays. So if we use this type of rules, quote-unquote checklist, this is perfect. Mentioned that book. All those checklists, one before, so all the threat models, during, so it will prevent the AI agent to introduce hard-coded credentials or SQL injections or the vulnerabilities that we don't even know that exist, now, because technology is going to change. And then the after is the code review. And also, if you think about it from a true end-to-end perspective, if it is finding vulnerabilities that was also present in code, it can even generate the test cases, what we call exploits, right? Which is kind of scary. But it can generate that, but it can test in runtime.
Right.
If, that's actually exploitable or not. And that's one of the biggest nightmares for pretty much everybody in security.
Yeah, we call it simulation, but you're right. It's just testing in real time.
Exactly.
Yep.
And that's where NVIDIA is headed too, right? They're looking at it, I think, explicitly in terms of like robotics and like how you'd be able to train a robot to do the dishes without breaking plates, but it applies to this as well. Like the more robust you can bake in these simulations, where it can run through checklists and then explore possible outcomes, the more it can narrow the ability to prevent security threats, right?
Yeah, and also the what we're doing. So whenever we build any agentic solution now, we always have an agent eval, which so the old world was like, you run through code, you get an error, you give the user an error, call support, or try again later. Well, now that's an agent, but let's say it's like an integration challenge, an API failed, or it failed to understand or read some object. It can edit that function in code and reattempt it for the user in real time. So essentially, you're not like reporting the bug, then waiting for a human to pull it out of a ticket, then go reproduce it, then go fix it. You're talking about someone runs into an issue, it literally fixes it on the fly, repairs, keeps the user moving, and then puts it in a queue for someone to review and permanently add, which is crazy, really. Like, just, it changes everything, doesn't it? And kind of to your point, now it's not about writing code, it's about how to make sure it doesn't do something wrong in that process, something insecure, like the checklists.
100%. As a matter of fact, I think the future, what you're going to see, technology will take us there, hopefully, but is that if I am interacting with a third party or getting a third party technology, I may actually have my evaluators. So it will be my checklist to evaluate your program, your product, etc., automatically. And at the end of the day, everything in security is, of course, around authorization and identity, but it's trust, right? And to trust, whether it's regulated trust or self-inflicted trust, you're gonna have to have that type of checklist. So imagine now if you're acquiring a new product, and you have your agents that instead of sending, hey, do a pen test on these elements, you have your agents to automatically evaluate what are the simulations and potential opportunities that an attacker can actually do this, right, on the fly, and then do all these simulations in a way that goes way beyond a traditional red teaming or pen testing, right?
Right.
Because it's not about...
What is interesting? Oh, yeah, go ahead.
Yeah, and to close on that, it's not about the vulnerabilities you have at that is at that time, because it's all point in time, all pen testing and red teaming, is simulating the different ways that you can actually configure a product, deploy a software, whether it's software as a service and you do a couple of tweaks, or an infrastructure device, that is controlling half of the internet, right? I think that this technology has some possibility of doing that type of simulation in different configuration modes.
Something I wanted to hit on, this, I feel pretty confident when I say this. I know it's a bit of a prediction here, but I think you're living in the future, so you can tell us what's there. I think there's this concept people have that if I don't do anything, my security's fine. Like, there's this false sense of like not understanding that the whole world has become a much bigger threat than it ever has, and that all of your traditional software has gone from like safe to unsafe, and that doing nothing is like not locking your doors and windows because you lived in a nice neighborhood and you didn't have to. It's not, if you do nothing, you'll stay secure.
Well, just to add on to that too, I think last time we talked, we were talking about this idea of outbound AI in the hands of consumers, and how consumer adoption seems to be outpacing organizational adoption significantly enough that's kind of a hidden threat that's hiding in plain sight, right? Like, people could very easily mount all sorts of novel attacks on organizations that they're barely even thinking about.
Yeah, you're spot on. And that strategic update that I mentioned to you, we were talking about the Chrome kitties, right? Basically, right now, a teenager with $100 and access to Claude can potentially write way better code than probably somebody that was a nation state attacker to compromise the system, for sure, right? And to Robert's point, if you don't do nothing, you're going to come to the realization that you have to do something, because if you're a business, you have to do business. If you're in a business, then you just stop. And then everybody else is actually doing something with AI. Everybody else will actually expect that you will talk to some type of AI system, some automated to do transactions. It's like going back in time and say, hey, I'm going to actually walk to your office in New York from Raleigh, North Carolina, and then I'm going to hand you a whole bunch of coins to do business with you. Of course, people are going to look at you. It's like, what are you talking about? Right? And then even if you go back in time and just 20 years ago and you said, hey, in order for me to do business with you, you have to be API driven. So API first, same thing.
Yeah, but also security, like, it's just, I think that's just the part that how vulnerable we all just became. And I think I fear, when I fear AI, in those moments I do, which is sometimes, I don't fear AI itself. I fear the panic buying of AI. I fear companies waiting, thinking they have time, and then finding out that, the rest of the world is sort of way ahead, and that they're behind, and then they just buy, and they're not educated. Like, this new security world isn't about buying a new firewall, right? It's educating people. It's culture. It's so much. It is buying a new firewall, but it's all of that.
As a matter of fact, you just brought something that, we were discussing in the coalition is if AI is actually going to be creating code way faster and, hopefully a little bit better in the future. Typically, whenever you buy, whether it's a security product or some third-party, software, it has 100 features. You use one. You're gonna have an agent that is actually just gonna create your new security, product because you can do it and have all those checklists and evaluations in place and everything. And since you're gonna just use one of the features, probably the other one is liability. And some people probably wants to have that risk to somebody else. So time will tell, but definitely, now that more organizations are going to be adopting these coding agents, and hopefully they will become better. The notion of actually just buying a security product, in the future, you will probably be comparing that product to your own, quote unquote, vibe coding, internal to your organization, right? And you maybe even move faster with less money.
Yeah, I've struggled with this a lot. If I do it in the human form, it's like every employee now is going to come with a security guard that stands over their shoulder and reviews everything they're going to do before they do it. And I just don't believe in that anymore. This security as an afterthought, or don't worry about security. We'll hand that to someone else to worry about. So examples is these these models that are pure, what they call them, like LLM firewalls or whatever. I don't use them, so I don't know the names of them. But these are like supposed to protect you from prompt injections, but what I worry about is that it sort of becomes this checkbox security thing again, where then the customers don't understand the nature of the vulnerabilities that they're protecting against, and they just think plugging in one of these things makes them safe, and that allows the teams that are building these things not to put in the checkboxes, not to put it, like, that security has to be woven throughout the whole thing from beginning to end. So maybe you have an eval of some kind, that's fine, as long as it's part of a greater design. But this world where you just go buy a product, plug it in, and go, oh, yeah, I don't have to worry about that because I've got a generative AI firewall, whatever the heck that is. Yeah, I don't know. I wanted to know your thoughts on that.
Yeah, I think that if it's only putting guardrails everywhere, you're probably not going to address definitely you're not going to address security at all. The other one is, I look at the defense of AI in 4 different type of personas. You still have to have some type of course, monitoring for probably AI agents to look at the system, and if it's something that catastrophically, deviates from the norm, if it's definitely it's PII in an output
Right.
or a prompt, block it, right? I mean, that's a given. But the other persona is around validation, and that's another challenge too, because how do you validate your AI application or your agent, etc.? You can red team a model to infinity. These are non-deterministic elements. You can talk to it and generate prompts, malicious prompts, and it will reply to you, right? And then you're going to have an evaluator, and of course, you're going to evaluate that, and you're going to continue until the rest of the infinity. We have to come up in the industry with somewhat of a passing score, or a feel-good score, that you say, okay, I'm going to actually go ahead and put this into production. And unfortunately, there's no standard for that, right?
Yeah, I've been talking.
Benchmarks, and then you're done with it, and you move on.
Yeah, I've been talking a lot about this. I think, I like to borrow these things from mature industries. I think it's always surprising me how little transfer we actually do, especially in tech, looking at other industries that have been doing a long time. And I think about drug trials and and drug creation, because we've sort of moved into that mode where drugs have like an efficacy rate. Like they're designed with the idea that there will be some failure, there will be some, some negative side effects, some, benign side effects. It will work on some people, and they have a set of, unfortunately, complex algorithms that we're going to have to lean into complexity on this one, that say, well, really, you're really kind of putting these scales on that say, well, what is the benefit? If 10% live, but 90% have benign side effects, it's okay. If 10% live and 10% die, it's not okay. And so I think we can borrow from an industry that develops drugs, that tests them, that has very significant analytics around that testing, specific algorithms that you can employ. There are certain ones where you can minimize the amount of negative side effects. So if it does come into one, it stops, and sort of optimize. And then there's also the trying to pre-qualify before you give them the drug. And then there's also the simulation of, let's simulate this person getting it before we actually give it to them. And so I know it's an imperfect system, but it sure is a lot closer than our software systems are today. Yep. I don't know what your thoughts are.
No, I think you're spot on. The elements, even if you look at what Anthropic is doing with ASL, and ASL, the AI safety levels, it was not around just, software engineering or AI and so on. It was around the in their case, bio and chemical weapon, safety levels. But there's a lot of safety levels that we can actually adopt that, right? Now, it's a little bit subjective, depending on who you ask, and what are the levels of an AI model right now. But I think that most people are agreeing that we're at level 3. And exactly what you mentioned, and I wanted to pick your brain on something. Imagine if we go to level 4, which, again, we're going to put these models into a bigger data centers. We most definitely going to hit level 4. And I'm not talking about AGI or superintelligence. I leave that to somebody else to talk about. But if we go to ASL 4, should that technology be open source, for example? So in that case, if we go to level 4, should that be open source? Well, you may argue it's like, well, the more open that we are, the more bigger the ecosystem actually can look at explainability and and advance the technology. So again, I'm contributed to open source all my life, so I can vouch to that. But whenever it comes to these levels, it makes you think, right? The other one
to me, it's like, would you ever do open source cancer drugs?
Exactly. And that was the same analogy. Actually, matter of fact, the argument was, if you want to cure cancer, should you be invited in an AI lab and not be, these models to not even be exposed to the internet, right? So then you start talking about AI sovereignty, and you start talking about, who's actually invited or not, and it gets super complicated.
Yeah. It's we get into the world of like, is there a right and a wrong? And the answer is, it really just depends. Someone's going to open source it. So I think we can talk about what we think is right or wrong. And I think to me, it's clear. You don't open source cancer drugs. I mean, you can take whatever you want yourself, but you can't give it to anyone else. But what I would say is it doesn't matter what I think, because it's going to happen. So it's more like, how can people protect themselves from it, right? And from this sort of thing happening. And I think again, I don't think there's like specific things kind of as you've been talking about. It's more of a mindset. It's just, it's being there. It's staying on top of this stuff, carrying, not thinking security is boring, not looking at this podcast and being like, oh, security, that's not for me. It's like, it's like, oh, it's for everyone now. And this is all there is to talk about, really. If you want to deploy this stuff practically, I'd say the center of the conversation is security, because there is no deploying it without that. But yeah, it's an interesting thought. I am always constantly battling with, should have OpenAI open source this or not, and then I realized, like, it's not going to matter. It's going to get out there. Someone's going to do it. So then it kind of comes down to more like their responsibility to create a safe place for it.
It's almost like an expanded version of what we were talking about with outbound AI in the hands of consumers, right? Like you have to start planning for that contingency, right?
Not because I want it, but because I just think it's going to happen. I think the whole private network thing is where this is all going. Like, people are going to need a safe place. That doesn't mean that the internet won't exist, but I think it's more than ever, they're going to need a safe network, a trusted private network that they can go to that has specific rules to be able to get onto it. Cisco's world, really.
Yeah, and it's a pretty complex, set of questions that we have ahead of us whenever it comes to, as you mentioned, somebody is going to distill your model anyways. If it's actually, out there, it's going to create somewhat of a replica. However, the other thing, as you were talking, is around going back to agents and specifically coding agents. We were talking about that, whenever you onboard a person, you go through the onboarding process, you introduce it to the team, you go into the guiding principles of the company, how you can take VTO or PTO, whatever we call it nowadays. And then all that, the onboarding process of an agent has to be with security in mind from the beginning. Like, this already automatically became your insider threat. Like, so exactly what you mentioned around the security. In my case, I was, opening some remarks the other day that says security is dead, but then I kind of fixed it afterwards, because we have to make security easier, right? It has to be embedded. If we don't make security easier, then we're going to lose the security problem. And if we if you think about a lot of the security capabilities that we embed into coding is very reactive, right? Yeah. A lot of companies, actually even open source projects, if they do have a NASPOM, they do it at the end of the project, right? We have to make security simpler, and we have to make it that is embedded, that is difficult.
Yeah.
Not an easy task that you can turn on the thing. But now you're thinking about these agents that are now entities that became your insider threat, but they never sleep. That they operate in some cases for 30 hours or for some cases for 30 milliseconds. They're getting access to the same data that you have. And of course, there's no true one-size-fits-all identity and authorization solutions out there for them. We're getting better. But so all those are going to be definitely the questions that we have to address in the next 12 to 18 months. We have no choice.
Yeah. Well, Omar, what do you think about like the composition of like a security team and security leads in companies? Because it's easy to imagine, like Rob brought up Amazon Q, and we talked to Tim Wood, who was a design lead on that, and he described that a lot of the work for companies using it is like almost like swipe right, swipe left. Like as things are migrating over, it's like, do you need this? Can this look like this? And you're making those kind of decisions. So you could imagine like someone on a security team spending a lot of their time like being presented with choices on things that are coming through the system and making those decisions. But then there also might be this element of that kind of relates to simulation, right? Where your job is to try and feed the agent, give the agent ideas for things to simulate. It's almost like trying to figure out ways to break the system, but asking like, well, what would happen if someone did this? What happens if party A does this and then party B comes in and does this? Like, how are we compromised? How can we work around that? And it is almost like that efficacy thing where then security is always present and it's always a little bit in flux and it's always being fine-tuned. And so you're kind of always moving towards being more effective in that way.
As a matter of fact, the concept of simulation, of course, exists for quite some time. It's just that now we're better at everywhere. We used to have these digital twins that now people call about agents of themselves, which is, they're calling digital twins of this. But digital twins for infrastructure devices. We had that for a long time, right? We have automation and where can this device be configured in a way? Can this device can be in a different way? And then you simulate the traffic that was going into it. You simulate how an attack and the attack path. And what if you didn't have, visibility like NetFlow back in the day, in some of the, or still today. And so that type of simulation is definitely what is going to be the next attack surface management, right? You do it for attack surface management, you depend on like combination of scans and showdown and OSINT, etc. But now you can have again agents that don't sleep, that is actually trying to actually see what an attacker would have done or can do from an inside, from outside, from the side, from everywhere, right? And then at the end you may have these entities that they will compare nodes. And then we'll decide what is actually the most effective mitigation technique for you. And then you should be able to spend some time, because it's absolutely impossible for a human to evaluate all these type of scenarios.
Yeah.
It's actually impossible.
Yeah, you almost want like a paranoid system, right?
Absolutely.
Like a system that believes it's always under attack. So it's just always on edge.
Yeah. But one thing I'd also like to point out, to your point of silos, or the breaking down of silos, if you can simulate an attack on your system, or you could simulate, a vulnerability of a physical product that you send out, right? You can simulate business decisions. You can simulate what happens if you raise the price of something or lower the price of something. Like, these are not in a silo anymore. It becomes a gray area of what is the simulation objective. Is it to secure the product? Is it to sell more of it? Is it, it really starts to merge in, and you can see that you can't just relegate this to one silo of the company, because the data you need to properly simulate has to come from everywhere. And then the implications of what you learn need to go back out to everywhere.
Yeah.
It's like a business function.
You brought something super relevant. Imagine, of course, we're talking about security here, but we have a simulation of an attack, or many, many permutations of an attack against a system, organization, company. And then you can simulate what happens afterwards. Your brand recognition, your customers calling your technical assistance center, all that, your costs, how long is it actually going to take to remediate based on previous incidents. You can start simulating all that, and you have the end-to-end business impact, not just that I launch an attack and compromise.
Oh, that's super interesting. You're right. Yeah. What is the cost? What is the risk? What is the cost to mitigate the risk? It's like your own actuarial data on a per vulnerability basis. Yeah. It's like crazy. You're like becoming an insurance company.
I think that cyber insurance has to move that way, right? And you create a profile of your company, and then they start doing simulations, and for all your premium and insurance is actually going like this every week. You never know. But,
crazy.
Yeah.
Well, this was great. I love this as much as the first conversations. So anyway, this was great. Thanks for coming on.
Well, thank you for having me. Hopefully this was useful.
Thanks, Josh.
All right. Well, thanks for hanging out with us again here on Invisible Machines. Don't forget to like and subscribe wherever you get your podcasts. Always remember that you can watch this podcast too on our Invisible Machines YouTube channel. Head over to uxmag.com. We have a podcast page there where you can explore our back catalog and you can look at episodes centered around popular topics. Many, many thanks to our incredible production team here in the US and in Ukraine. Elias Parker, Michael Litvinov, Allison Harshberger, Alla Slesarenko, Vera Pokodkov, and Darina Moskovchuk. Till next week, Owagi.